Hello everyone and welcome to another Maths tutorial video. Now I am going to discuss Form 5 Additional Mathematics Chapter 3 Integration Part 2 video. Before I begin, if you are new to any of my videos, please do subscribe to my channel and hit the notification bell as I'll be discussing more mathematics tutorial video in the future. Alright guys, without further delay, let's jump to the question now. As you are looking right now is the example 3 long question, Chapter 3 Integration question. Let's read the question together. The diagram shows the curve y equals to x minus 1, bracket x plus 1 and a bracket 3 minus x. So this is the graph and this is the shaded region. This is the function. So the question asks to find the area of the shaded region, guys. Okay, by the way, before I forget, in this video I'm going to discuss two long questions of integration, guys. So please stay till the end. Okay, by the way, I hope you will attempt this question in the future. If you could attempt this question in the future, well done guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions now. Alright guys, I hope you are as excited as I am. Let's jump to the solution now. Okay, let's begin to show the solution. Okay, the first step in solving this question is we need to identify the roots to set the limits of the integration, because we are finding the area of the shaded region, and then we need to calculate the area of the positive and then the negative region, and for that we need to identify the roots, guys. Okay, so I've already drawn the graph over here. So in order to give a explanation for you, so you might be wondering how I get negative 1 and 1 and 3 over here. Well, it's very obvious, guys. In the question they already give us the root, we just have to make it into 0. Okay, the first one, x plus 1 is equals to 0. So we make our y function is equal to 0. So from here we get our first root, x equals to negative 1, which is the negative x coordinate, guys. So continue for the second root, x minus 1 equals to 0. And then we will get our x equals to 1. So this will be our second root. And then our third root, 3 minus x equals to 0. And then you should be getting your x equals to 3. So this is your third root. It makes sense, guys, because our graph function is y to the power, x to the power of 3. So technically you should be having 3 roots over here. 1 intercept, 2 intercept and 3 intercepts over here. So we have already have 3 limits, which is our 3 roots, negative 1, 1 and 3. So let us proceed to the next step. So the next step, we need to form expression y in terms of x. So in the question, they have already given us y equals to x minus 1 in a bracket x plus 1 in a bracket 3 minus x. It's all in the factored form. So what we're going to do now is we're going to expand this bracket one by one. So to form an expression y in terms of x. So we expand x minus 1 and x plus 1 first. So from here you get x squared minus 1 and then 3 minus x. So what you're going to do, we're going to further expand this bracket. And from here, you'll be getting 3x squared minus x cubed minus 3 plus x. So when you rearrange this equation, since this equation is a bit unorganized, so what you're going to do is we're going to rearrange this equation in the descending order, which is the degree of power of 3, 2, 1 and followed by 0. So from here, y is equals to negative x cubed plus 3x squared plus x minus 3. So we have already rearranged the equation so that it will be easier for you to solve for your integration later on. Alright guys, we have already formed our expression y in terms of x over here, because we are solving this integration in terms of x. So we are finding the area under the x region. We are not finding in terms of y, but we are finding in terms of x. That's why we are finding here the expression of y in terms of x. Alright guys, we have already identified the roots and we have already formed an expression of y in terms of x. So now I'm going to show you the next step, so please hold on. Okay, once you have already successfully identified the limits, and then you have already express your equation y in terms of x, now you can calculate the area of shaded region. Okay, by the way guys, before I forget, I should remind you that there is one area under the graph is in the negative region. So when the area under the graph is in the negative region, you need to consider that as a positive area, not a negative area guys, because area should be in a scalar value, not a minus value. Okay, so for the area under the graph for 1 and 0, what we're going to do, we're going to add a modular sign over here, because we're going to find the area of the shaded region. Because from 1 and 3 it is a continuous graph guys, but then our 1 and 0 falls under the negative region. To calculate the area under the negative region, what we do is we set our integration in a modular sign. So whatever negative value we get back the positive value. Okay, from here we set our limit 1 0, and then we insert the expression y, and then respect to dx. We have already identified our expression y is negative x cubed plus 3x squared plus x minus 3 respect to dx. And then we plus with integration with the limit of 3 and 1, with the expression of y equals to negative x cubed plus 3x squared plus x minus 3 dx. Okay, we have already write down the equation. Now we can proceed to solve the integration. Okay, for the first part 1 and 0, negative x power of 3, so x power of 3 will be increased the power by 1, so you'll get x power of 4. That 4 you need to divide as well, so from here you get negative x power of 4 over 4. 3x squared, x squared will increase the power by 1, so you'll get 3x cubed. So when you proceed to the next step over here, so when your power add on by 1, so 3x power of 3, the power you need to divide as self. So 3x power of 3 divided by 3, you should be getting x cubed. Okay, proceed for the next one. Your x power will be increased by 1, so from there you'll get x squared. That power, the 2 you need to divide as well. So from there you get x squared over 2. So this 3, your x in the beginning is in the power of 0, so you add the power by 1, so from here you get minus 3x with the limit 1 and 0 guys. And the same thing is over here, negative x power of 4 divided by 4 plus x cubed plus x squared over 2 minus 3x with the limit 3 and 1. Okay, so what we do is we substitute in the upper limit value and the lower limit value respectively for 1 and 0, and also for 3 and 1. Okay, proceed to the next step. Okay, these are the calculation guys. Negative 1 power of 4 divided by 4 plus 1 cube plus 1 square over 2 minus 3 times 1. This is the upper limit value 1, and then you minus with the 0. Why I just immediately put 0 here guys? Because as you notice here, 0 divided by 4 you get 0, 0 here you get 0, 0 divided by 2 you get 0, and then negative 3 times by 0 you get 0. So I just write here minus 0 to save the working guys. And then you plus, and then you put the limit of the 3, negative 3 power of 4 divided by 4 plus 3 cube plus 3 square over 2 minus 3 in a bracket 3, and then you minus with the limit of 1, which I've already found before, and then we just have to rewrite over here guys. Okay, so far so good. So proceed to the next working. So from here, for the limit 1 0, you will be getting negative 7 over 4 guys. But then for the second one, you should be getting 9 over 4 minus negative 7 over 4. 9 over 4 minus negative 7 over 4, you get is 16 over 4. 16 over 4 is also known as a whole number 4 guys. So negative 7 over 4, since you have a modular sign over here, which is makes sense, negative 7 over 4 indicates that your area is in the negative region. But then your area is a scalar value, guys, so you change back into a positive value by adding a modulus over here. So from here, 7 over 4 plus with 4, you should be getting your answer 23 over 4 unit square, or you can write in the mixed fraction, which is 5 3 over 4 unit square. If you write in either one, it's acceptable, guys. Okay, that is all for my example 3 step-by-step working in the solutions. So please hold on, I'm going to show you the example 4 in a while. Okay, welcome back. So we are now proceeding with the example 4 long question, chapter 3 integration. Okay, let's read the question together. The diagram shows part of the curve y square equals to 4x. The straight line y equals to p divides the shaded region into two regions A and B. As you can see here, this is the shaded region of A, which is from the limit 1 up to limit p, and then this is the shaded region B, starts from limit p up to limit 4. Okay, proceed with the question. Given that the ratio of the area of the region A to the area of the region B is 1:8. So the question asks to find the value of P, guys. Alright guys, I hope you'll attempt this question in the future. If you could manage to solve this question, well done guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions now. Okay, proceed with the solution. Okay, for the first step, what you're going to do is we change the y square expression to x in terms of y, because we are finding the area in terms of y-axis. In this case, the question is not in the x-axis, guys, but then the area under the y-axis. So we're going to change the y square expression to x in terms of y. Okay, let us continue. So from here, we write down y square equals to 4x. So we can express our x equals to y square divided by 4. So this is the expression of x in terms of y, guys. So we have already successfully done our first step. So proceed to the next step. Setting up comparison based on the ratio. In the question, they already give us that the ratio of area region A and region B is 1:8. So we're going to set up the comparison for the both of the region. So A is to B is given as 1:8. So A over B is equals to 1/8. We can write our ratio in the fraction form as well, guys. So from here, we can form our comparison. B is equals to 8/8. So this is the relation between the area B and then area A, guys. So B is equals to 8 times as area A. Okay, so we've already formed the comparison, and then we have already changed our expression x in terms of y. So guess what, guys? Now we are going to proceed to calculate the area A and area B to find the P value, because they have already gave us the ratio, guys. So it will be easy for us to find the limit value. Okay, we will be proceeding our working in the next page. Okay, it's given as B is equals to 8A. Okay, from here, integration with the limit for P, and then you do an integration of x in terms of dy. So x is equals to y square over 4, y square over 4 dy is equals to 8 times of area A, which is the limit of P, and then 1 y square over 4 respect to dy. Okay, proceed guys to the next step. So what we're going to do here, we're going to factor out the constant. Since y square over 4, we can factor out with y square times 1 over 4. The 1 over 4 is a constant, guys, so we can remove it out of the integration. So 1 over 4 with the integration of 4p y square with respect to dy equals to 8 over 4 integration with the limit p and 1 y square with respect to dy. So 8 over 4 you should be getting is 2. So since y square and y square, so we no need to make any arrangements or in the fraction form, so we can proceed to calculate our integration. Okay, So y square, you increase the power by 1, so you get y cube, and that power you need to divide as well, so you get y cube divided by 3. So for the both side, the first one you calculate with the limit 4 and p, and the second one you calculate with respect to limit p and limit 1. So what we're going to do now is we're going to substitute each limits over here, the upper limit and the lower limit value for 4 and p, and then the upper limit value p and the lower limit value 1 for this right hand side region respectively. Okay, proceed to the next step, guys. Okay, so 1 over 4 in a bracket 64 over 3 minus p cube over 3 equals to 2 in a bracket p cube over 3 minus 1 over 3. Okay, so let us proceed. So from here you get 64 over 12 minus p cube over 12 equals to 2p cube over 3 minus 2 over 3. Okay, let us continue to the next step. So from here you can combine these two into one single fraction, these two fraction into one single fraction. 64 minus p cube divided by 12, 2p cube minus 3 minus 2 over 3, you can combine into one whole fraction equals to 2p cube minus 2 over 3. Okay, what you can do is, so you can cross multiply your fraction. From here you get 192 minus 3p cube equals to 24p cube minus 24. Okay, we are almost done with our calculating with our limit. So you regroup the p in one side and then the numbers in another side. So in this case, 24p cube, you bring the negative 3p cube, which is in the left hand side, to the right hand side. So you will get 27p cube. And negative 24 from the right hand side, you move it to the left hand side, which you get 192 plus 24, which you get is 216. So p cube is equals to 216 divided by 27, which you get is 8. And therefore, to find p, you cube root the 8, and you should be getting p is equals to 2. So this is your final answer, guys. Alright guys, I hope you get the step-by-step working and the solution for this question. Okay, alright guys, that is all for my step-by-step working and the solution for this video. Any question or feedback, feel free to put in the comment section below. If you like this video, please give a thumbs up. If you haven't subscribed to the channel, please do subscribe and click the bell icon as well. Thank you for your support, guys, and I will see you in the next video.